Hello everyone, welcome to Mewadus digital channel. In this video, we'll be taking the topic swords. Swords are roots of irrational numbers, e.g. root 2, root 7, root 12, root 18, etc. are all swords. Now, before we proceed, we need to take rules of sword. Now, let's denote we have root A times root B. Now, if we have this case, root A times root B, this is equals to root A times B. That is, they mean the same thing like this. Let's take an example to show that. In a case whereby we have root 4 times root 9, this is the same thing as root 4 times 9. Here we have root 4 is same thing as 2, root 9 same thing as 3, and this is going to give us 6. Here as well, you can also see root 4 times 9 will give us 36, and square root of 36 will give us 6. First rule there. In a case we have a over b, square root of a over b, or root a over b, this is same thing as root a over root b. Independently, they both share this root, so the numerator will take its root and the denominator will take its root. An example, if we have root 16 over 4, root 16 over 4 is the same thing as root 16 over root 4. Here, you agree with me that this means 4 divided by 16 gives us 4, and here root 16 is 4, and root 4 is 2. Square root of 4 will give us 2, and 4 divided by 2 will give us 2. Since our LHS, our left hand side, is equal to the right hand side, that means this is correct. So that means if we have root A over B, it's same thing as root A over root B. Third, if we have root A plus B, this is not equals to root A plus root B. Now let's take an example as well to show this. If we have root 4 plus 9, root 4 plus 9 will give us root 13, and square root of 13 here should give us something around 3.60555. We check that from our calculator. Then if we now have root 4 plus root 9, here you see that square root of 4 is going to give us 2, square root of 9 is going to give us 3. 3 plus 2 will give us 5. Here we'll see that here that square root of 4 plus 9 is not equals to square root of 4 plus square root of 9. So that has shown our third law. Fourth here, if we also have root A all minus B, it is not equals to root A minus root B. Let's take an example as well here. If we have 25 minus 9, this is going to give us root 16, and that's going to give us 4. If we take root 25 minus root 9, here we are going to have 5 minus 3, and 5 minus 3 here is going to give us 2. It's also clear here that root 25 minus 9 is not equals to root 25 minus root 9. Basic form of surd. We also need to basic form of surd. Yeah, in dealing with surd, we also need to understand this basic form of surd because this is one of the basics we need to understand so that we can deal with questions or problem with surd. Now, if for instance you have root A, for this root A to be in its basic form, it means that it does not have A does not have a factor that is a perfect square. It means that root this A for root A for this surd here to be in its basic form, it means that this A does not have a factor, does not have a factor that is a perfect square. That is not a perfect square. Now, what do you mean by perfect square? Perfect square are just numbers that you can multiply them by themselves, or numbers that when you take their square root, they will give us exactly a whole number. Now, e.g., if you have root 6 here is in its basic form, root 2 is in its basic form, root 5 is in its basic form, root 7 is in its basic form, root 11 here is in its basic form. Now look at it here. Root 8 is root 8 in its basic form. Root 8 is not in its basic form. Root 8 is not in its basic form. Why is root 8 not in its basic form? We can still root 8 is not in basic form. Why? Because we can still get one of the factors of 8 is a perfect square. That is, we could still have root 8 to be root 4 times 2. This 4 here is a perfect square. From the law of indices that we started with, that means we could have root 4 times root 2. And this is going to give us 2 root 2. 2 root 2. So that is why root 8 here is not in its basic form. So the basic form of root 8 is 2 root 2. Because if we check here now, this number under the root sign, this root sign, or you call it radical, here is not a perfect square and doesn't have a factor that's a perfect square. So that makes 2 root 2 to be in its basic form, but root 8 not in its basic form. Let's look at another case. Root 18 is not in its basic form. Why is root 18 not in its basic form? Because we can still split root 18 as 9 times 2. That means one of the factor here is a perfect square, meaning we have this to be what? Root 9 times root 2, and that's going to give us 3 root 2. Here, 3 root 2 is in its basic form. Here is basic form, but root 18 is not in its basic form. Another one. If we have, say, we have root 50. Root 50 as well is not in its basic form. Why? Because root 50 can still be splitted into one perfect square and a non-perfect square, that is 25 times 2. Why this is going to give us 5 root 2. So root 50 is not in its basic form, but 5 root 2 is in its basic form. Similar similar surd. Similar surd. Surds are similar if they have the same number under the square root. Now, or we can say surds are similar if the rational parts contain the same number or numeral. E.g. now, e.g. 5 root n and 7 root n are similar surds. Why? Because they have n here. Under the square root here, you have n. So they are similar surds. Likewise, 3 root 2 and 5 root 2 are similar surds. Then, e.g. now, you have 3 root 3 and 3 root 5 are not similar surds. These similar surds are important because we need them to be able to solve operations or deal with operation in sort like multiplication, addition, and subtraction. They are more like terms as we have in algebra, like terms. So similar sort is also something like that. Of sort, simplification of sorts. Sorts can either be simplified in their simplest form or as a single sort. Let's take some example here. Examples. Simplify root 45. To simplify root 45, here in this case, what we want to do here is that we want to express this sort in the simplest form because we can still have root 45 here is the same thing as root 9 times 5. And this is the same thing as root 9 times root 5. From the rule of indices, the first rule, root 9 times root 5. This is 3 times root 5. And that will give us 3 root 5. Another one, number 2. Root 8. To simplify root 8 simply means to express it in its basic form, which is going to give us root 4 times 2, and that's root 4 times root 2, and that's going to give us 2 times root 2, and we have 2 root 2. Example 3. If we have root 108, 108, we want to simplify this as well too. All you just need to do is you need to find a way to write this in the simplest form. Now we have to split 108 into 2 so that one of the factor is going to be a perfect square and the other is going to be a non-perfect square. To do that, we are going to have this, we first split as 9 times 12. 9 is a perfect square and 12 is not a perfect square, but we can still split this 12 to also be a perfect square and the other being a non-perfect square. That is, this could still be 9 times 4 times 3. Here from the rule that we started, this is same thing as root 9 times root 4 times root 3. This is going to give us 3 times root 4 is going to give us 2 times root 3. Then 3 times 2 give us 6 root 3. We have simplified root 108. That means basically what I've done here is we have expressed square root of 108 in its basic form. which is 6 root 3. The fourth example, we have 5 square root of a cube b. We have this, we want to simplify this as well. This is the same thing as 5 times square root of a raised to power 3 times b times b, which this can be splitted as 5 times a cube times square root of b, which this is 5 times, this is going to give us a square times a times root b. Then this is going to give us 5 times a cube, means a square times a. Square root of a square will give us a times root a times root b. Then here we are going to have 5 a times root a times root b. This is going to be 5a times root ab. Then we can say this is 5a root ab. We have expressed or simplified this in its basic form. We are still under the simplification of Surds. Like I said earlier, simplification of Surds can be either to express in the simplest form or express in this in a single form. Express the following as a single Surd. We have 1, 3 root 2. Here we want to express 3 root 2 as a single Surd. All we just need to do is this. We want it to be so that we'll be not having 3 outside. We want all these numbers to be under the root. What you do in this case is this: write the root. This 3, take it in 3, square it and multiply it by the 2. Here we are going to have square root of 3 square is 9, that is 3 times 3, and times 2 here is going to give us root 18. We have expressed 3 root 2 as a single Surd. Another example, if we have 2 root 13, like we have solved the first one, all we do is write the roots, bring the 2 in, square it and multiply by 13. Then we have square root of 2 raised to power 2 give us 4 times 13. 4 times 13 will give us 52. We have expressed 2 root 13 as a single Surd. 2 root 13 will be equals to root 52. Another example, if we have s raised to power 3 root y, we have this case. We are also to express it as a single Surd. Same thing is applicable here. We draw the root sign, bring this in, s raised to power 3, and multiply the power by 2. That is, we have times y. This is the same thing as s raised to power 6, because 3 times 2, power times power, 3 times 2 give us 6 times y. Here, we are going to have s raised to power 6y. we have express x raised to power 3 root y in as a single surd. So we have x raised to power 6 root x raised to power 6y. Operations with surd. Under surd, we can carry out different operations in surds. The operations that are possible can do are addition and subtraction, two, multiplication, and we can also have division. We take some example under addition and subtraction. For us to carry out addition and subtraction in surd, they must be in the basic surd, and also they must be a similar surd for you to be able to add the surds together, and for you to be able to subtract, they must also be similar surd. Let's take an example for that. Example: simplify root 2 plus root 2. If you are to simplify this surd, you have root 2 plus root 2. Now, one of the key things to take note when adding and subtracting surd is, one, they must be in the basic form. Look at the surd. If the surds are in their basic form, after that, check to see if you now have similar surd. You agree with me that in this first case, root 2 and this root 2 are in their basic form and they are similar surd. Now, this is synonymous to 2 root 2, meaning here is 1 and 1. Then we have together, that means you're having 2 root 2. Another example, if we have root 4 plus root 5, here in this case, you can see they are different, so they are not similar. So root 4 is not similar to root 5. Then what do you do? Now, I said earlier, check the surd if they are in their basic form and if they are similar. We check the condition for similar, so they are not similar. So we cannot add up like this first example. Then check root 4. Root 4 is not in basic form. That means you can write this to be in basic form. You agree that root 4 is the same thing as 2 plus root 5. Now, can we proceed further? No, we cannot proceed further. Why? Because this is 2 whole number and this is surd. You cannot add them together. Also similar like when we have in algebra, if we have a case of x and you have y, you cannot add x and y, they are not the same term. Same thing as applicable here. This is 2 and this is root 5. This is a surd, this is a whole number. You cannot add it together to give an answer in this format. Another example, if we have 4 root 3 minus 2 root 3. In this case here, we have the first part here is 4 root 3, the second is 2 root 3. If you check root 3, these surds are similar surd. In this case now that we have similar surd, all we just do is this. We just have to say 4 minus 2 root 3. That's going to give us 2 root 3. What we have just done here is similar to what we do in algebra. Say we have 4x minus 2x. All just do is subtract this 4 minus 2, 2, and we have our x. Same thing is applicable here. They are similar surd. Since they are similar, all just do is subtract the whole number part. 4 minus 2 equals 3. Another case, if we have root 32 plus 3 root 8. Root 32, we have root 32 plus 3 root 8. Now, if we are to add these two together, firstly, root 32 and root 8 are not similar surds. So what we first need to do is we need to first what's it called? Put root 32 in the basic form and put root 8, 3 root 8 also in the basic form. Here, this is root 16 times 2 plus 3 root 4 times 2. If you agree with me, this is 4 root 2 plus, if you agree with me, this is 3 times 2 root 2. And this is 4 root 2 plus 6 root 2. Now, you now have similar sort, root 2 root 2. What you just do is 4 plus 6 root 2. 4 plus 6 is going to give us 10, and you have root 2. That means you have 10 root 2. Example 5. 5 root 3 plus 2 root 2 minus 3 root 3 minus root 2. Now, if we check in this case, we have similar sort. 5 root 3 here, 3 root 3 are similar. Root 2 here and root 2 are similar. What we'll do is we'll group similar, those ones that are like, together. That is, we have 5 root 3 minus 3 root 3 plus 2 root 2 minus root 2. Now, this and this are similar, this and these are similar. 5 root 3 minus 3 root 3, that will give us 2 root 3, plus 2 root 2 minus root 2, that's going to give us plus root 2. Now, can we simplify further? No, because here root 3 and here is root 2. They are not similar sorts, so we leave our answer like this. Now we take multiplication of surds. Multiplication of surds. Let's take some examples. Simplify root 18 times root 32. We have to simplify this. To simplify this, all we first need to do is express each of these surds here in their basic form. Then when they're in their basic form, we multiply. Then we have root 18 times root 32 . Now this is going to give us root 9 times 2 times root 16 times 2. This is 3 root 2 times 4 root 2. Now, the next thing to do is multiply this part and this part. 3 times 4, and the root part will take root 2 times root 2. Then you have 12 times root 2 times root 2 give us 2. That means 12 times 2 will give us 24. That means simplifying this will give us 24. Alternatively, you could decide to go through this other approach by saying root 18, by saying root 18 times root 32. Following the multiplication rule of sort, the first rule we discuss, that is, we say root 18 times 32, but that is going to give us a large value. It's going to take time, so it's just better to quickly simplify like this and we move through. Another example, root 45 times root 28. What we'll do here also is express this in its basic form. Is going to give us 9 times 5. Express this in its basic form is going to give us 4 times 7. Here is 3 root 5 times 2 root 7. This is going to give us, multiply the whole number part, 3 times 2 times root 5 times root 7. This is going to give us 6 times root 45. 4 times 5, 5 times 7 here is going to give us 35. Then we have it with what? 6 root 35. Another example, root 24 times root 72 times 3 root 5. What we'll do is we express each of these in their basic form. This is going to give us 4 times 6 times 36 times 2 times 3 root 5. We agree with me, this is 2 root 6 times 6 root 2 times 3 root 5. Here we have 2 times 6, multiplying the 2 times 6 times 3 times root 6 times root 2 times root 5. This is going to give us 2 times 6 times 3 is going to give us 36 times root 6 times root 2 will give us 12, or we could have it like this: 6 times 2 times 5. Then we have 36 times 6 times 2 will give us 12. 12 times 5 will give us 60. Here you have root 60. Root 60. But if you agree with me, we can still split root 60 here in the basic form. We can still write root 60 in its basic form. That is, we could have 4 times 12. No, it could be split as 4 times 15. Then we have 36 times 2 root 15. Then we have 36 times 2 give us 72 root 15. We have simplified this. These are examples on multiplications of sort. Example 4 here, 4 root 3 all squared. This is also the same thing as 4 root 3 times 4 root 3. Here we are going to have 4 times 4 times root 3 times root 3. Here we have 4 times 4, 16, times root 3 times 3, we have 3. Then you have 16 times 3, that is going to give us 48. Then you have alternatively, if you don't want to solve this using this approach, you could also solve it like this. You have 4 root 3 all raised to power 2. Here we could apply rule of indices here. From this rule of indices here, we have x raised to power xy raised to power a. There are videos on indices. We are going to have x raised to power a, y raised to power a. So that means we are going to have 4 raised to power 2. Then you have cube root, root 3. Then you are going to have 16. This cancels out. Square root of 3 raised to power 2 is going to give us 3. Then you are going to have 16 times 3, 48. You see, we still arrive at the same answer. So that we solve it like this, we solve it like this. Now we take rationalization of surd. Now, rationalization of surd is just removing the irrational part from the denominator. Now, if we have a over root b, when we rationalize this, it means that we want to remove the root b here from the denominator. And how do we do that? We are going to multiply to rationalize this. We multiply the numerator and denominator by root b. That is, we have a over root b times root b over root b. This will give us a root b over b. Now, in this case, we have rationalized this surd. Now, rationalization of surd is applied when one is dealing with division of surd, because is one of those approach that are used when you are dealing with division of surd. Let's take some example. Division of surd. Example. Simplify 6 over root 3. In this case, to simplify this, what we are going to do is we are going to rationalize this. That's, we are going to multiply the numerator and denominator by root 3. Root 3, root 3, because the denominator here is a surd, and to rationalize means we must remove this surd from the denominator. How do we do that? Is by multiplying the numerator and denominator by root 3. This is going to give us 6 root 3. Root 3 times root 3 will give us 3, and that's going to give us 2 root 3. Another example. We have 5 over root 12. To simplify this, what we also do is to rationalize. That means we multiply the numerator and denominator by root 12 times root 12 over root 12. This is going to give us 5 root 12 over root 12 times root 12 will give us 12. So we have rationalized that. Our answer is going to be 5 over root 12. But let's look at it further. This root 12 we have is not in its basic form. We discussed basic form earlier, that we ensure that surd is always in its basic form. Then what do we do? Since it's not in its basic form, we have 5 root 4 times 3 all over 12, and that's going to give us 5 times 2 root 3 all over 12, which is going to be 5 over 6. root 3. 2 goes here 1 and 2 goes here 6. So we have 5 over 6 root 3. So our answer is 5 over 6 root 3. Now if we have this kind of question, an objective question, if we stop here, most likely the answer is not going to be there because it is not in the simple form, because the question instruction is simplified. So since this is not in basic form, we ensure we put it in basic form. That's why we have 5 over 6 root 3. Let's take example 3. We have 3 over 4 root 3. Now in this case, to simplify this simply means we need to rationalize this. Then we have 3 over 4 root 3. Now the surd here is root 3. What we'll do is multiply numerator and denominator by what? Root 3. Then we are going to have 3 root 3, 4 times root 3 times root 3 is going to give us 3. Then we have 3 root 3 over 12, and that's going to give us 1 over 4 root 3. We have an answer like this, or we have root 3 over 4. Alternatively, we can also, we are going to have 3 times root 3 all over 4 times 3. That is 3 goes in 12. 12 and 16 has a common factor of 3. 3 goes here. 4 goes here 3. 4 goes in 16 4. Then we still have 3 will cancel this. So we are having root 3 over 4. We have done that. Let's take another example. Another one. We have root 12 over 81. Over 81. Now, to simplify this from the law of surd or rule of surd that we learned at the beginning, we have root 12 over root 81. This, we need to put them in their basic form. This is root 12 in the basic form is going to give us 2 root 3. Root 81 is 9. Then we have an answer to it. 2 root 3 over 9. Let's take another one. Here we have 25 over 3. Now this, conjugate of surd. Before we take conjugate of surd, let's quickly discuss what we mean by binomial surd. Binomial surd, example of binomial surd are root 2 plus root 3, root 5 minus root 2, 2 plus root 5, 7 minus root 3. Now, these are binomial 2. Now, a binomial surd is a surd containing the sum or difference of two surds or a surd and a rational number. Now, look at it. 2. You can see you have surd. The operation between them is plus. Surd minus. You have plus surd and the numbers plus minus surd and the numbers. So now, these are examples of what? Binomial surd. These are what we are going to be dealing with under conjugate of surd. Under conjugate of surd, conjugate of surd. Conjugate of surd. To get the conjugate of a surd, all we just need to do is we need to change the sign. Now, if we have root 2 plus 3, the conjugate of this surd is going to be root 2 minus root 3. For instance, e.g., you have a binomial surd to be a plus root b. The conjugate is a minus root b. Now, if we go to this as well, too, we are going to have the conjugate of this to be root 2 minus root b. Let's take some example. We have surds and you have conjugate. Here you have the surd and conjugate. We have 6 minus root 5. The conjugate of this is going to be 6 plus root 5. All it does is we change the sign here. You will have 3 root 2 plus root 3. The conjugate is going to be 3 root 2 minus root 3. If we have root 2 plus root 3, the conjugate is going to be root 2 minus root 3. That's how to get conjugate of surd. To get conjugate of surd, when you have the surd, all you just need to do is change the sign between them. Then we have the conjugate of surd. Well, rationalization of binomial surd. When rationalizing binomial surd is to multiply the binomial surd with its conjugate. E.g., we have root 3 minus 4 as a binomial surd. To rationalize this surd here, we need to multiply by its conjugate. And what's the conjugate of root 3 minus 4? The conjugate is root 3 plus 4. All we need to do is we multiply together. We have root 3 minus 4, root 3 plus 4. In this case, we expand. Root 3, use what you have here to expand this. Root 3 bracket root 3 plus 4 minus 4 bracket root 3 plus 4. This root 3 times root 3 will give us 3 plus root 3 times 4 will give us 4 root 3 minus here we have minus 4 times root 3 will give us 4 root 3 minus times plus minus 4 times 4 will give us 16. Then here we are going to have 3 plus 4 root 3 minus 4 root 3 is going to have 3 minus 16. Our answer 3 minus 16 is going to give us minus 13. We have it will be minus 13. Also, alternative way to do this is when we are dealing with binomial of surd. To rationalize the binomial of surd, we can apply the idea of difference of two square. Difference of two square. Difference of two square. The idea of difference of two square. This is what I mean by difference of two square. Difference of two squares, we have a square minus b square is going to be a minus b, close bracket a plus b. You can apply this when dealing with conjugate of binomial sort. Let's take this for example. If we have root 3 minus 4, we want to rationalize root 3 minus 4. We know that the conjugate is root 3 plus 4 we multiply. We are going to have root 3 minus 4 bracket root 3 plus 4. What this translates to, following the approach of difference of two squares, is just that take this here to be A and take this here to be B. Then we are going to have A square minus B square. Our A is root 3. That's going to be root 3 square minus our B is going to be 4 square. By the time we do that, root 3 square is going to give us 3 minus 4 square is going to give us 16. Then you can see we have the same part with what we have here. 3 minus 16 is going to give us minus 13. So alternatively, to rationalize binomial sort, to be able to walk through it quickly, it is best to apply the difference of two squares. We decide to go with this. This is easier. But it's going through the expansion approach, it's fine as well too. In both cases, what you are doing there is what? Rationalization of binomial sort. Let's take another example on rationalization of binomial sort. If we have 2 root 3 plus 4, to rationalize this, is going to be 2 root 3 plus 4. We'll multiply it by its conjugate, and the conjugate of this is 2 root 3 minus 4. Now, using the expansion approach, it's going to be 2 root 3 bracket 2 root 3 minus 4 plus 4 bracket 2 root 3 minus 4. Here, if we expand, we are going to have 2 times 2 give us 4. Root 3 times root 3 will give us 3 minus 8 root 3. This is plus. When you multiply 4 times this, 4 times 2 root 3, we are going to have 8 root 3. Plus times minus will give us minus. 4 times 4, we have 16. Now, this is going to give us 4 times 3, 12. Minus 8 root 3 plus 8 root 3 is gone. We have minus 16. Here you have 12 minus 16. It's going to give us minus 4. That's just that. If you want to use the alternative approach, or the alternative approach using the approach of difference of two squares, this is what we have. 2 root 3 plus 4. Like I explained previously, we are going to take this as, the whole of this as A, and we take this as B. Then using difference of two squares, A square minus B square. So we are going to have our A now to be 2 root 3 all squared minus our B 4 squared. Then this is going to give us, by the time we take the square of this, we are going to have 4 bracket 3, because this square, 2 square is 4. Root 3 square will give us 3 minus 16. We have 4 times 3, 12 minus 16. We still have 12 minus 16. That still gives us minus 4. You see, we have the same answer. It's either we'll go through this approach or make use of this approach. But this approach here is faster, applying difference of two squares and dealing with conjugate of binomial sort. Let's take some more examples applying the conjugate of sort. Examples. Simplify 3 over root 3 plus 2 by rationalizing the denominator. by rationalizing the denominator. Now, in this question, we're told to simplify this by rationalizing the denominator, to specify rationalize the denominator. But when we check the denominator here, we'll see that what we'll have by rationalizing here, you see that what we have in this denominator is a binomial surd. So we are going to rationalize by using the conjugate of surd here. Then we are going to have 3 over root 3 plus 2. Conjugate of root 3 plus 2 is root 3 minus 2. That means we are going to multiply the numerator and denominator by 3 by root 3 minus 2. The denominator as well with root 3 minus 2. Now we have, this is going to give us 3 bracket root 3 minus root 2 all over, this is going to give us root 3 plus 2 bracket root 3 minus 2. Here is going to give us 3 bracket root 3 minus root 2. Now, applying the difference of 2 square here to factorize it, to make us move faster, we are applying the difference of 2 square, we are going to have a square minus b square. We definitely know that our a, we are going to take root 3 as our a, then 2 as our b. Then that means we are going to have root 3 square minus our b, which is 2 square, which is going to give us 3 minus 4. So that means here we are going to have, after multiplying these two, that is, we are going to have 3 minus 4. 3 minus 4, then we are going to have 3 open bracket root 3 minus root 2 all over 3 minus 4 minus 1. If you agree with me, the same thing as 3 over minus 1 bracket root 3 minus root 2. Then here we are going to have minus 3 bracket root 3 minus root 2. In this case, we have simplified this. We have simplified 2 root 5 plus root 3 all over 3 root 5 minus root 3. Here we only have simplified. From seeing this, we can see that the numerator consists of a binomial surd and the denominator consists of a binomial surd. To simplify this, we are going to rationalize using conjugate of surd. Now, we are going to have 2 root 5 plus root 3 all over 3 root 5 minus root 3. We are going to multiply the numerator and denominator by the conjugate. That is, the conjugate is going to be 3 root 5 plus root 3 all over 3 root 5 plus root 3. We are now going to have, this to be 2 root 5, 3 root 5 plus root 3, we expand, plus root 3 bracket 3 root 5 plus root 3 all over, from where we have learned earlier, applying the difference of 2 square here, since they are conjugate of surd here, it will be faster for us to apply that. Definitely this is going to be 3 root 5 all squared minus root 3 all squared. You agree with me? Then by the time we expand here, we are going to have 2 root 5 times 3 root 5. Here we are going to have 6 bracket 5. 2 times 3 give us 6. Root 5 times root 5 give us 5. Then we have 2 root 5 multiplied by root 3. That's going to give us a plus 2 root 15. Then we have plus root 3 times this is going to give us plus root 3 times this is going to give us 3 root 15 as well. Plus 3 root 15 plus times plus will give us plus. Then you have root 3 times root 3, that's going to give us 3 all over here. This is going to give us 3 square, because the square of 3 here, this square is affecting the 2, you have 3 square, and here you have this minus this is going to give us 3. You agree with me? This is 6 times 5 30 plus 2 root 5 plus 3 root 5, that's going to give us plus 5 root 15 plus 3 all over 3 square will give us 9 bracket 5 minus 3. Then this is going to give us 30. Here and here we bring them together. 30 plus 3 plus 5 root 15 all over 45 minus 3. Then you agree with me? This is 33 plus 5 root 15 all over 42. Now this is our final answer, but check, root 15 is in its basic form. Yes, we cannot simplify further because you cannot split 15 to have a perfect square and a non-perfect square. So that means we have simplified this. This is now going to be our final answer. So we have come to the end of the topic Surds. One of the key in mastering this is solve more problem. Watch this video along, solve this problem, go to past questions, textbooks, solve more problems on Surds. The more problems you solve or the more questions you solve, it gives you confidence to be able to deal with questions on them. If you find this video useful, kindly share to your friends and colleagues, and don't forget to like, subscribe, and stay up with the channel for you to always get more mathematics topic. Thank you.